Hello everyone, thank you for tuning in. Today we're going to talk about Math 121, section 2.1, and that section deals with frequency distributions or frequency tables. So first, let's define what a frequency distribution is, and this shows how data are split into various categories by listing the categories and the number of data values in that category within that category. So it's a table that splits data into different categories. Sometimes it might be easier to know where data falls in categories. We're going to see a couple examples of this, but first, let's look at one that relates to, math class for us. Maybe we're talking about letter grades, A, B, C, D, and F. We've got grades and frequency. The grades and the frequency. So the frequency is how many people got those grades. Maybe we had 4 A's, 11 B's, 7 C's, 1 D, and 2 F's. Whatever numbers we feel like making up for our example. But maybe we had, that grade breakdown. Who knows? But we've got a table that splits the data into different categories, right? Now, many times we want our categories to be numeric rather than with, arbitrary letter grades. And for numeric categories, we're going to have limits on the categories themselves. And that's these first two definitions. The lower class limit is the smallest number that belongs to a class. Now the classes are the categories. So if you want to write classes equal categories, that is fine as well. The class is the word we usually use rather than categories. Class is a little shorter, right? Easier to say. So the lower class limit is the smallest number that belongs to a class. The upper class limit, same thing, but change the word smallest to largest. So this is the largest number that belongs to a class. The class boundaries are the numbers separated by the classes, the numbers used to separate the classes. So the class boundaries are the numbers used to separate the classes. So the class boundaries are the numbers used to separate the classes. The class midpoints are the values in the middle of the classes. Values in the middle of each class. The values in the middle of each class. To get this, well, if you want to know what numbers right in between the lower and upper limits, you can add the lower limit and the upper limit to get the class midpoint. And then the class width, well, that's the difference between two consecutive lower limits. How far apart are two back-to-back lower limits? So how far apart are two back-to-back lower limits? Now, there's a caution here. Class width is not upper limit minus lower limit. It's not the upper limit minus the lower limit, so be careful with that. That is not the class width. It is not upper limit minus lower limit. Not. It's different. We'll see the formula on the next page. Now, on our second page, in the interest of saving us some writing, let's read through this real quick. Step 1, select the number of classes. This will be given to you, right? If you were a researcher doing authentic research, you would choose how many classes you wanted. However, since this is a statistics course, and in the interest of keeping questions similar between students, you'll be given the number of classes. You won't get to choose the number of classes. Step 2, calculate the class width. The formula is that the width is equal to what? How do we calculate the width? Well, we're going to have three things we need to keep in the formula. The first number is the max data value. Whatever your largest data value is, you put that first. Then from that, you subtract the minimum data value. So you take the largest minus the smallest, and you divide by the number of classes. So if we want 5 classes, we divide by 5. If we want 5 categories, we would divide by 5. You take your biggest minus your smallest, divide by the number of classes. And then it says we round this to a convenient number. We almost always round up, and I will tell you how to round for most questions. In our class, we'll be rounding up most of the time. In real life, you pick how you round, right? You would choose how you want to round the classes because you'd be the researcher. You would know how you want to round. But for our purposes, we'll be given rounding instructions. Step 3, choose the value for the first lower class limit by either using the minimum data value or a convenient number right below the minimum. Usually it'll tell you the starting point if it's not going to be the minimum. Then it says using the value chosen in step 3 and your width found in step 2, list the other class limits, the lower limits, adding the width to the limits to get the next lower limit. That'll make sense when we see it worked out by hand, but for now, let's just ponder that. Step 5, determine the upper limits. Once again, this should be easy once you've done step 4, but might seem, cryptic at the moment. And then step 6, take each individual data value and tally them into the appropriate classes. This is time consuming because it's mostly busy work. You're just checking the boxes, but will be important to get correct. Now, McDonald's lunch service times. Use the table of lunch service times below to construct a frequency table. Use 5 classes. Round your class width up to the nearest 10 and use 75 as your first lower limit. All right, sweet. That gave me a lot of information. 5 classes. Now, since I know I'm going to need 5 classes, and it tells me how to round the width, let's calculate the width. I need to know what my maximum data value is. What's the biggest number in this table? Hopefully everyone agrees it's 308. Minus, what's the smallest number in this table? Well, if you take a look for a second, you'll see that it's not 91 or 90, but it's 83. And then we divide that by 5. And if I look here, 308 minus 83 divided by 5 gives me 45. And then it says round your width up to the nearest 10. The next multiple of 10 after that, I would round to 50. So I am going to use 50 as my width. Notice it told me how to round, and I rounded up. If this number was 41, I would still round up to 50 because it says round up. You don't follow conventional rounding rules if it tells you to round up, right? Now, select the number of classes. I was given 5. Calculate the width. I calculated the width. All right, cool. Step 3, choose your first limit. So, what are we measuring? We're measuring service time in seconds, right? We're going to start making our table. My first lower limit is 75. I'm going to put 75 right here. That's my first lower limit. Now, I use the width, step 4. Using the number from step 3, 75, and your width, get the other limits. I'm going to go up by 50, 125. Then 175 would be the next one. These are the lower limits. They're all 50 apart because 50 is the width. And then it would be 225, and then 275, and next would be 325. But I do not need 325. I'm going to scribble it here so we can see. 325. I do not need 325 because my largest number is 308. It's not going to fall in a category 325 and above. So these are the lower limits I need. I don't need this last one. I wrote it because we'll see that we don't need it in a moment. Now, I got the lower limits. Step 5, determine the upper limits. Well, what's the biggest number that is smaller than 125? Well, that's 124. Now, I did not include a decimal point. I could have wrote 124.9, or 124.99, or 124.999, right? That would all be smaller than 125. The reason I didn't include decimals is because my answers have no decimals. My data does not have decimal places. If these had decimal places, I would include the same number of decimal places here. So for example, if there was 2 decimal places here, I'd put 124.99 instead, because I keep the decimal places the same. Since I have none, I can use whole numbers. But you put the biggest number here that is still smaller than your next limit. So then it'd be 174, and then 224, and then 274. And then this last one, knowing this number was 325 helps me to know that I want to put 324 here, because it would be the next number below 325, right? So that is why this number can be useful. I didn't need to write it, so I'm going to cross it off now, because 308 will fall in this last category, right? Now, I like to write the words tally here, and then write the words frequency here. My answers are going to go here at the end, but I'm going to use this to work through the question. Now, how do I do this? Well, let's look at the first number in my table is 107. That falls in this first category, so I'm going to put a tally. Next is 139. That falls in the second category, right? It's between 125 and 174. 197 is in the third category. 209 is in the third, and so on and so forth. In the interest of time, so you're not just watching me tally things into boxes, I'm going to skip to the answers. I'm just going to put the correct number of tallies there. You need to work through your table. Next would be 281, and you'd put it here. Then you'd be 250, and so on. You need to work through the table to make sure you are tallying things correctly. However, to save time, let's just put the correct number here. The first one, we should have found 12. The second category, we should have found 23. The third category, we should have found 10. The fourth class, we should have found 3. And the last class, we should have found 2. So we'll get answers of 12, 23, 10, 3, and 2. 12 in the first category, 23 in the second category, 10 in the third category, 3 in the last, or 3 in the second to last, and 2 in the last, right? This is how many of these data values were in it. I can kind of check to make sure I did it right. There were how many data values here? Well, if you counted them up, there's 50 numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, so on and so forth, up to 50. If I add these numbers up, it better add up to 50. 12 and 23 is 35, 10 more is 45, 48, 50. I know I have all the numbers now. I didn't miss one. Always double check you didn't miss one. It's real easy when tallying things to miss one. This is actually the easiest step to mess up once you get the hang of frequency tables. Tallying can be the most difficult step. It's time consuming. It can be easy to blur the numbers in your head, to flip, instead of reading as 113, Maybe I goofed and said 131 in my head. That would change what category I'm in, right? I want to be careful to make sure I'm counting correctly. Work through it slowly and carefully. So that's our frequency table. Now, this would be the end of the question, if the question was to create the table. But I wanted to talk a little bit about the class definitions we had from the previous page. The lower class limits. What are the lower limits for this table? Well, the lower limits are 75, 125, 175, 225, and 275, right? That's the lower limits. What about the upper limits? 124, 174, 224, 274, 324. That's the upper limits. What about the class boundaries? Let's write them. Class boundaries. These are the numbers on the border. 124 and 125. What number is on the borderline there? It would be 124.5. That's the number that's on the borderline here, right? How about 174 and 175? That would be 174.5. The next one would be 224.5, right? Then it'd be 274.5. 274.5. Now, I need the beginning and ending number as well. 324, what would the next class be? Would be 325, right? So the last number would be 324.5, following the same pattern, right? And I also need the starting boundary, which would be 74 and a half. 74.5. So we need starting and end points as well. And notice it follows the same pattern of being off by a half. So those are the boundaries. What about the midpoints? Well, if I want to find a midpoint, let's say I'm looking at the midpoint, and I want to find class midpoints. Well, there's 1, 2, 3, 4, 5 classes. I should have 5 midpoints. The way we find them is we find the number right in between 75 and 124. 75 plus 124 divided by 2. 99.5 is my first class midpoint. 99.5. My second one, 125 plus 174 divided by 2 gives me 149.5. Similarly, if I did 175 and 224, 175 plus 224, for my third class, divide by 2, I get 199.5. My fourth class, 225 plus 274, divide by 2 gives me 249.5. And then the last midpoint would be 275 plus 324, divide by 2 gives me 299.5. So, boundaries and midpoints, make sure you note the difference. The boundaries are the numbers halfway between the end of one and the beginning of next. That's the boundaries. They're on the boundary. The midpoints are within the classes themselves. They're midpoints, right? Make sure you know the difference. So these are separate. This is the table. That's what we were trying to create. This is understanding the definitions, right? Making sure we remember our definitions from earlier. So that's making our first table. Notice it didn't take too long. The longest part is honestly tallying the numbers into the table. Will be the most time-consuming part. Now, what about a relative frequency distribution? Well, a relative frequency distribution displays the relative frequency instead. So here, it is a frequency, I'm abbreviate frequency table, that shows the percentage of data in each class. And then a cumulative frequency distribution is a frequency table, so is a frequency table that shows the running total in each class. So for a cumulative table, you keep a running total. For a relative table, you keep a percentage. Now, it says use the table from the other example. Let's copy down what it was. So, we'll copy down our example. So here's what we had earlier. It was 12, 23, 10, 3, and 2. We already had this. We already did this, right? This is already done, and this was service, time, and this was frequency. So we already calculated this table. So we're going to use it from the other example. We're going to make a relative distribution instead. So let's do that first. We're still measuring service time, but now instead, we're keeping track of the relative frequency, which you might want to write a little percentage sign next to help you remember. My categories do not change. So let's copy down our 5 classes. Now, I need percentages here. I need to know the total data. Remember, the total was 50. There was a total of 50, right? If I added these up, I'd get 50. What I do is I take each class and calculate the percentage. 12 over 50, what is that as a percentage? 12 over 50. Well, if I take my calculator and do 12 divided by 50, and then to make it a percent, you multiply by 100, right? I'm going to get 24%. So the first answer is 24%. And then I'm going to do 23 over 50, which if you work it out will give you 46%. Then 10 over 50, which will give me 20%. And then 3 over 50, which will give me 6%. And then 2 over 50, which will give me 4%. So I wanted these percentages here. My first category had 24% of the data in that class. My second had 46%. My third, 20%. My fourth, 6%. And my last, 4%. These are the percentages, right? I have how much data is in each one as a percentage. That's the relative frequency. So that's relative. How about cumulative? Well, for cumulative, we're going to put cumulative frequency here. And then here, we're going to put service times. But my categories are going to change. My first category is going to be less than 125. Why 125? Well, because every number in this category is less than 125, right? Because that's the next one. My second category would be less than 175, because every number in the second class is less than 175. Notice I'm keeping inequalities, and I'm going to follow that pattern. My third category will be less than 225. My fourth will be less than 275. And my last one will be less than, it ends at 324, so my value would be 325. Notice we're using the next category's lower limit and the words less than 125. Now, we need to keep a running total. How many numbers were less than 125? Well, that's only these 12 in the first category. However, how many numbers were less than 175? That are the numbers in both of these categories, aren't they? This category and this category are smaller than 175. And there's 35 numbers in those categories. So I'm going to put 35 in the second category. Now, my third category says less than 225. I need to combine the first 3 categories, because all 3 are less than 225, right? 224, 174, yeah, those are all less than. And that gives me 45. Now, My fourth category, I need the ones less than 275. Well, that's only going to add this extra 3, so there'll be 48 numbers that are less than 275. Lastly, 325. Well, all of my numbers are less than 325, aren't they? So this better be 50. And if I check the running total, it is 50. The last number will always be your total in a cumulative frequency table. You're keeping a running total. You better get to the overall total by the end, right? Notice it kept increasing, right? It's a running total. It should always increase because you're adding new data points in each category. Less than 125, less than 175, less than 225, less than 275, and less than 325. They have new descriptors, right? So notice, with a relative frequency table, you just need to calculate the percentages. With a cumulative frequency table, you needed to reorient your categories so that they're inequalities, and then keep a running total. And that's the difference between a standard frequency table, a relative frequency table, and a cumulative frequency table. A lot of similarities. The standard is the usual example. Relative frequency is when you want to talk about percentages, and cumulative frequency is when we want to talk about running totals. I always like to think of snowfall for cumulative frequency. Cumulative snowfall, things like that, right? We see the word cumulative when we talk about snowfall. Relative frequency, the word relative, if you're speaking relatively, you're talking in terms of percentages, right? Like, $1 million is not very much money for Jeff Bezos, relatively speaking. Is $1 million a lot of money? Well, yeah, it's a ton of money, right? But compared to how much money Jeff Bezos has, it is very insignificant. It's relatively small, right? That can help you keep track of cumulative versus relative. So, we've got 3 flavors of tables. Let's look at an example of them side by side, comparing McDonald's and Dunkin' Donuts. The table below represents the relative frequency distributions for a set of data involving McDonald's service times side by side with a table for Dunkin' Donuts service times. And notice, I've got my categories, I've got my relative frequencies, and I got some percentages. What can we notice? Which place is faster? Can I tell that? Which place takes longer? McDonald's looks like it takes longer. Most of the data in Dunkin' Donuts is before the data in the McDonald's service time. So, based on the table, I can conclude that Dunkin' has faster service times. And that should make sense, right? When people go to Dunkin', they're usually getting a coffee, a donut, something quick. When you go to McDonald's, you're usually getting a sandwich or French fries or something a little bit longer, right? They're both quick, right? They're both fast food, but there are differences. Which has a faster service time? So if you're in a hurry, that might play a factor. Maybe you own the McDonald's and you're losing all your business to the Dunkin' Donuts across the street here in Saranac Lake. Well, this shows you that one advantage they have over you is service time. So if you can reduce your service time, you may be able to compete better. You can look at information side by side, right? You can draw conclusions when looking at things side by side. All right, now let's do another example. This one is going to be a little bit different. It says, use the list of data values below representing Exam 1 scores for an Intro to Stats course to create a relative frequency distribution. Use the minimum as your starting point and a width of 10. I don't need to calculate the width. It told me it was 10. Cool. Width equals 10. All right, good to know. Use the minimum as your starting point. So, we got grades. We're going to need the frequency. And remember, we actually want to calculate relative frequency when all is said and done. So, what is the minimum data value? Well, 68 so far, 42. Looks like 42. So I'm going to start with 42 and use a width of 10. My next category will start with 52, then 62, 72, 82, 92. Well, next would be 102, but I'm not going to need 102, am I? I'm going to write it down here on the bottom just so we can see we won't need it, but that's where I'm going to stop. Notice I went up by 10. 10, 10, 10, 10, 10. Now, the upper limits. Do I have decimal places? No. So I can put whole numbers here. I don't need decimals. What's the biggest whole number that's smaller than 52? 51. And then smaller than 62? 61. 71, 81, 91. Let's see. What would be here? Well, the next category would be 102 if I needed it. So this would be 101. Did anybody get over 100? No. It doesn't matter, though. The classes follow the pattern. Make sure you're following the pattern. Don't try and input your outside knowledge. Do we know that a 100 was the maximum score for this test? No. Maybe it was out of 107 points. We can't tell that from this, right? We do not have that information, so we should not cap our data at 100. We should respect the pattern. Now, frequency. Notice I didn't put tally. It's because with this small data set, maybe we don't need to tally. Let's look. We're looking for 42 to 51. Well, let's see. We've got 1, 2. We've got 2 data points there. Notice I crossed them off as I went. 52 to 61. Let's see. None, none, and none. So we've got 0 in that category. There's nothing in that category. So I'll put a 0. It's okay for a category to be empty. Next, we've got 62 to 71. Well, let's see. We've got 1, 2, 3. We've got 3, it looks like. 72 to 81. Let's see. 1, 2, 3, 4. I've got 4 in that category. 82 to 91. This one looks like it's going to be flush with numbers. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There are 10 numbers in that category. And then the last one, 92 to 101, I've got 1, and it looks like just 1, right? Now, I need to check that I got them all. Let's see. 5, 9, 19, 20. There should be 20 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we got them all. Always good to check the total. So there was 20 total. And I'm going to need this 20 because I need to calculate the relative frequency. 2 over 20 as a percentage is 10%. 0 out of 20, well, that one's pretty easy, 0%, right? 3 out of 20 will be 15%. 4 out of 20 will be 20%. 10 out of 20, well, that one's pretty easy too, right? That's 50%. And then 1 out of 20, that's back to 5%. So 10%, 0%, 15%, 20%, 50%, and 5%. These are the numbers I wanted, right? These are the relative frequencies. Now, if I goofed up my categories, I can't finish the question properly, can I? Because all of my frequencies are going to then be wrong. It's super important you always double check your upper and lower limits. Make sure you've done them correctly. Otherwise, after you count everything to the correct groups, the groups aren't going to be correct if the groups themselves are incorrect, right? So be careful with that. Like I said, it can be easy to get lost in the numbers and miscount or misgroup something. So always double check. Always be patient. Take your time when you're tallying things, right? And just be careful. And that brings us to the end of section 2.1. Thank you for joining me, and I will see you next time.